Hi, folks, and welcome to today's lesson in British Columbia Institute of Technology, Technology Teacher Education, TTED 4010, where we're learning how to program an Arduino, amongst a few other things. And in today's lesson, I want to talk about what the heck is a void loop anyway. When you start doing text-based coding in the Arduino, which uses a variant of the C language, um, you're going to see this thing called a void loop. Void setup and void loop are the two main parts of your program. And unless you have a little bit of understanding what goes on in there, it's kind of cryptic. And in the process of talking about the loops, we're going to talk about a couple of the brackets that are used. Really, programming languages use every bracket on your keyboard because they're really good at hugging things and keeping them together. But we've got the squiggle brackets, as I like to call them, the ellipses, and then we've just got our regular brackets or round brackets right over here. And they have different functions. And if you leave them out or put them in the wrong place when you're doing text-based coding, the computer is going to chuck an error message in your general direction. Or worse, you might just happen to get two wrongs that sort of make a right that lets you compile, and it compiles and runs something that you don't want it to run, and you don't find out your problem until later on. So there really is a big difference between the squiggly brackets and the round brackets. And in the process of doing that, we're going to talk about functions, loops, and variable definitions for the Arduino IDE. And we're going to start this journey heading over to vr.vex.com, where we spent a little bit of time already this semester. And then we're going to go to Tinkercad for doing all of our actual Arduino work, because their Tinkercad simulator's pretty awesome. So, okay, let's get started here. And let's not go to Tinkercad first. Let's go to Vex Code VR now. If you're playing along in the home game, particularly if you've got two monitors, why not bring up your web browser and go over to vr.vex.com and get logged in so that you can play along and see what we're experiencing here. All right, now in class, a couple weeks ago, we were doing some work with Vex Code VR. And we used it to write a program that would let your robot go out and draw a circle on the screen. And we made that circle into a subroutine, also known as a function or a block in the block programming way. And that's actually pretty critical to understanding some of the things that you're going to see with void loop and void setup and why the heck they say void anyway. So we're going to come back in here and we're just going to do something really simple. We are going to create a function that lets a robot go out and it's going to drive in a square of a particular distance. And then we're going to take a look at what the code looks like for that in Vex Code VR. And we're going to transfer it over to Tinkercad and see what it looks like in the Arduino. Now, in order to do that, we needed to make our own block. So making a block, we called ours circle when we wrote the block, but I'm going to write this one and call it square. Okay. And square is going to need an input number, okay, because we're going to input the length of each side of that square. Okay. And so we're going to pass a variable from our main program to the function, and that's going to help it understand what it's going to do. Okay, easy enough. If I tell you to draw a square, I'm going to say draw a square 40 millimeters on a side. That 40 millimeters is going to be a variable. Okay, so now you'll see it uses the word define right in here. Let me get rid of a couple. Don't need that Arduino sitting there right now. And I'm just going to shrink myself down here a little bit and get out of your way. Hi, I'm down here now. Okay, um, so we're going to use this and we're defining our function called square and we're going to pass a number to it. Now, I want to change that from saying number, I want to change that to side. Actually, I'm going to do this, side length. There we go. You see how I got those capitals in there? Capitals are another fun thing that you're going to have to make sure you get 100% correct when you're typing in your program. Okay, now this program right here, is just in blocks, but it's already starting to show some important things that are coming along that we're going to take a look at in a minute. And let's see, new blocks project, new text project. We can do blocks or text in here. I want to view the text for this. Right. Had to pause that for a second. It's this button up here that I was looking for over in the top corner. Uh, it's got brackets on it. I should have known. Hit the brackets button, and you can see that the code comes up right in here. And it uses a slightly different format than what the Arduino is going to use because it's written in a slightly different language. But in here, it starts by saying, hey, I've got a variable called 0. Um, so this is called our variable declarations. And then it's got this function here for defining the square, okay? And the square is going to be passed a variable right in here, and it's going to call that side length, okay? And then that's going to come down here. And then we've got the when started coming right in here. Now this is the equivalent of your void setup in the Arduino, which then translates into your forever loop, the void loop. We'll take a look at how that comes together. So maybe turn on your code viewer and you should have a block here. And now we're going to put some routines in here. We're just going to go into the drivetrain, and to drive our square, we're going to drive forward, okay, for side length millimeters, okay. We're going to turn right, and now I've got a couple choices. You can see this coming in here, drivetrain, drive, forward, and there's that side length variable comes in there, okay. So we're still working on the function right in here. I've got a couple of different choices. I can repeat this code 4 different times, or I can use some control code in here, and I can tell the computer to repeat it 4 times for me. Okay, and now this is written in Python, so it's going to look a little bit different than it looks in our Arduino, but you can see it's putting this in right here, and Python uses indentations. Rather than brackets, but you'll see in the Arduino that we use brackets because this part right in here, okay, right in here, is all contained in this statement right up here. Okay, great. So this is going to come out, it's going to execute all that, and then it's going to head back to when started. So if I wanted to drive a square, I could come in here and I could say, come down to my blocks, and I could say square 50. And now I could hit on that and I can run my code. Now that doesn't quite look right. What's happening with my code? Did I forget to tell it to wait? Oh, I just told it to turn right. Wrong command in here. Get rid of that command. Drivetrain, turn right for 90 degrees. Hope you caught that while I was going along. Let's check that out. It's pretty common to have a little glitch when you're writing a bit of code. There we go. Wow, that was exciting, eh? And so you can have it do a square of 50, and then you can come along here and you can have it do a square of 250. There's our square of 50, and there's our square of 250. So thrilling. Now, from the point of view of the code, when it's running, it comes in here, it gets to square, it says, all right, do I have a block named square? Do I have a function, a routine named square? And if I do, I'm going to jump to there. I'm going to pass it this variable 50. That variable is going to get passed in here and it's going to get stored as the variable side length. This function is going to do whatever it needs to do. and then it returns back over here and carries on. So basically, you could have the exact same code, but you'd have to put this code into here and into here and into here. We're defining our own function in here. And so therefore, in our main loop, we can just call that routine when we need it to be there. It's almost like we've created our very own personal function or command or macro or whatever you want to call it in the code. Now, although this is a different programming language, you'll notice that it is using brackets right around here. And what it's using brackets for is to separate things that are being passed back and forth or used in a command. Okay, and that's a very important part of the round brackets. We'll take a look at the squiggle brackets in a minute when we get over to taking a look at the Arduino. But I wanted to come back here and just take a look at it because this ability to create a function or to create a block doesn't really exist in Tinkercad. We're going to have to do it using the text-based routine. And I just wanted to show it here so we're thinking about it on the same page. A couple of things that we also thought about when we were doing this was whether when we create a variable, because we created some variables, we said make a variable and give it a new variable name. Let's say robots rule. Okay, we now have a new variable up here called robots rule. And so that's been defined right up there as 0. And when we come in here and set a variable to something, set robots rule to, okay, we can now use robots rule right in there so that we can have functions that loop around in here. Now, why would we want to do that? Well, that's because we can do something really cool on here. Okay, instead of just setting it to 250, we can make that setting be a little bit more dynamic by creating a loop in here. And we can say while, okay, robots rule. We need a less than command in here. Okay, is less than 1000. Do a square at robots rule, and then change robots rule by 10. So now it will, now let's do it by 100, otherwise it's going to get. And now over here, you can see we've got the while statement come through. It does a comparison right here. And so long as this statement is true, it'll come down to the bottom of this indented code and loop back up into here. And you can see that we've got those orange arms grabbing the code. You know, you've got the top orange arm right in here, the bottom orange arm. Here's another top orange. Those are grabbing it and holding that chunk together. And in the Arduino, that's what we're going to use squiggle brackets for. The squiggle brackets are basically a big hug that holds a chunk of code together, just like these orange arms do right in here. Okay, and now if I start this up, it's going to start at 0, and there's a square with sides of 0. There's 100. There's 200. Right, we'll leave the little robot to do its thing. Okay, now let's pop over to Tinkercad because Tinkercad is going to let us see all this on the Arduino, and that's our end goal. That's what we're going for. So come into Tinkercad and log in with your Autodesk account. Okay, where am I on here? There we go. All right, and we're going to come over here once you're signed in to Tinkercad. And we are going to go to Tinker, and we are going to go to Circuit, and we are going to start tinkering. Now I'm back here. Projects. Oh, gallery. No. Where am I in here anyway? Circuits. Start tinkering. Oh, there we go. Designs. My designs. Tutorials. Uh, designs. There we go. Designs. Circuits. I want a new one. Circuits. New. New circuit. Oh, I knew that had to be around somewhere. All right. Okay. So I'm gonna move myself off of over here. I think I'm best to sit in this bottom corner of the screen right now as we go through and set all this up. So let's take a look at all the components in here, and we're gonna come down just like we did before, and we're gonna grab an Arduino and a breadboard. There's Arduinos in here somewhere. Um, we can get to them quicker if we just go Arduino. There we go, with a breadboard. Bring it in right there. And now we have an Arduino on a breadboard. Let's go back to all right here. Okay, so our Arduino's in here. It's got a breadboard. Let's take a look at some of the code that comes up just by default. So we're going to come in here. We're going to take a look at our code, and we're going to pull up the blocks plus text option. Okay, and just as our Vex Code VR code had a bunch of setup stuff going on, so does our Arduino program. And so you can see we come in here to void setup brackets brackets. Okay, squiggle bracket, pin mode, LED built into output. Close that off right there. Okay, so this is that equivalent section. This runs once at the very start of the program. So when your program starts up, it comes in here. It sees this weird line called void setup, which I'll explain in just a moment. And then it runs through whatever's in between these brackets. It does that once. And then it comes down here, and this becomes a forever loop, an endless loop that keeps repeating over and over and over again, while as long as your Arduino is plugged in, okay, um, and not giving off too much smoke. And so in this case, it's just going to do a digital write. It's going to turn the built-in LED on high, going to wait for a second, close it off right in there. So nothing too fancy. If I start the simulation, comes in here, and there's the built-in LED blinking on and off. Yay, got that? Blinking on and off. And we can play around with different things in here, but we want to talk about what the heck is going on with this void setup. Now, the Tinkercad IDE doesn't give me the opportunity to create a function or a new block in here. We're actually going to have to go in and use the text-based programming to do that. And I'll show you a bit more on that in just a minute. But if I was creating a new function in here, my function needs to have a variable passed to it. And that's what this bracket bracket means right in here. This means that setup does not expect anyone to be passing any variables into it. And void loop does not expect to be receiving any variables. Okay, so in square, we set up our function and it expected to receive a variable. So when we sent it 50, that was the length of a side. Well, there's other ways to create functions. They don't all need to be passed variables. And setup and loop are not passed any variables. We just tell them, hey, go execute this code. We don't give them a number to do it with. The void part means that when this is all finished, it's not going to return any values, okay? Because a function can do two different things. Well, it can do many different things. You can pass some code to it. It can go out and do a whole bunch of various things and then return a number. So if you think about something like the square function, I used it to draw a square, but the mathematical square function, you know, a squared plus b squared equals c squared sort of thing. If you wanted to get a squared, there's not a command for that in well, in the Tinkercad math anyway. So what you would do is you would create your own function and you would say, if I send you a number, multiply it by itself and then send that number back to me, please. Okay, so if you had a function called square, it would say, actually, wouldn't say void loop, it would actually say int loop. I'll explain that in a minute. And it would expect a variable right in here. Okay, why don't we actually try that? Okay, so in order to do that, we have to go to text-based coding on here. Da 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 da. Okay, are you sure you want to continue? Yes, let's continue on right here. And now we're in text-based coding, and this is where typos really start to matter. Okay, and so what we're going to do up here, no more blocks. Uh, we are going to come in here and we're going to go serial dot begin brackets 9600. Okay, now here we've got some round brackets. Now what the round brackets are doing is they're saying that this number right here, 9600, which is the bit rate that the serial port is going to communicate at, basically a higher number, and it talks faster. For those of you with, you know, gray hair like mine, you'll remember the old days of 300 bits per second or 300 baud modems. We were very excited when we got up to 9600 bits per second on our modems. Modems were a thing that you connected your computer, allowed your computer to connect to the telephone so that you could call the internet. We didn't call it the internet right away, but anyway, that was a while ago. So we've got serial begin 9600, and every line has to end with a semicolon so that it knows the line has come to an end. Now, okay. Now, after doing that, just go start simulation right here, and it will debug your code. Now, if it comes up and it's running like this, that's great. Let's stop the simulation. If it's not doing that, maybe it's because you made a mistake in capitalization. For instance, if I said serial dot capital begin, and I asked it to start the simulation, I'd get an error. Okay, so I can close that. And you'll see that there is an error down here. Now, what the error means, 510, okay, you'll see that we're in row 5, line 5 of your program. And if you come over to column 10, the 10th character in, okay, that's where it detected the error. And although class hardware serial has no member name begin, doesn't make much sense, it offers a helpful piece of advice. Did I mean small b begin? Yes, I did. Okay, same thing if you miss the S. Oh, keep doing that automatically. And you put a small s in there. Okay, S is void setup. So it tells you what function we're in. It says line 5, row 3, serial was not declared in this scope, which means I have no idea what you're talking about. Suggested alternative is capital S serial. So if you've got errors, sometimes it will actually help you out a little bit. Okay, now I'm just going to ditch some of this code from void loop. Okay. Oh, I need to stop the simulation to do that. If it's not responding, check to make sure that your simulation stopped. Now try coming in here and try this. We're going to say, print, serial dot print brackets, because this is something, this is a value that we're passing to the serial print command. Quotes, because we're passing it words instead of numbers. Hello. Serial.print the square of Okay, so it's going to, now I've put this into different lines for a reason here. Okay, so let's start this simulation and turn on your serial monitor. And you'll notice that it keeps doing this forever. Hello, the square root of 5, stop the simulation, this is going crazy. It's all coming out on one line, and it's repeating forever. Well, of course it's repeating forever, because this loop repeats forever. And it's coming out on one line because we never actually sent a carriage return character. To do that, we use the serial.println command. ln stands for new line. Don't ask me why it's not serial print NL, okay? But I just sometimes call this serial print line um, or serial print line. Uh, but if you put that ln after the print, you will get a carriage return. And we'll do that down here too. And you'll have that popping up. So this all stays together on one line. And you'll see why I've got this set up a little bit separate in just a moment. Okay, now we're going to do a function to do a mathematical square here. And so what we're going to do is we're going to come down here and we're going to say int square int x. Okay, and then we're going to open up some big huggy brackets right in there. Okay, now you'll notice that I've got int where this said void. Remember that void means that the function will return nothing. Int means that the function will return a variable of the integer type. I know I haven't explained what an integer type variable is. We'll get there. You can't explain everything all at once. But it will return an integer type variable. So it's going to return a number. And it is expecting to be passed a number as well, also an integer. Okay. And then between the opening squiggly bracket, the opening ellipsis, and the end ellipsis, it's going to do something in here. Okay. So we are going to create a new variable. We are going to say int y equals x times x. Return y. Let's just check our code right here. If I start simulation, look at that. It compiles. It doesn't work. It doesn't do anything unusual. Let's stop the simulation. I just wanted to make sure I had that all typed out. This code never actually gets executed right now because we don't have it do anything. I am now going to go serial.print line brackets square brackets 5. Okay, now you do have to watch the number of opening and closing brackets here because the outside brackets are what's being passed to the serial print line command. And to figure out what's being passed over there, the computer looks at what's inside here and says, oh, I have to do that square thing, and I have to pass square the number 5. Hello, the square of 5 is 25. Now I can change my formatting up a little bit if I want it all on one line. I get rid of that print ln right there. Okay. And now I've got something that for now until the rest of eternity can tell me what the square of 5 is. Okay, so what's happening right in here? Well, the code starts right here. Now, you see these double backslashes? That means that anything that follows that on that line is a comment. It's there for humans. The computer completely ignores it. So you could come in here and write booga, booga, booga. And while that's not real helpful for the next programmer coming along, it makes just as much sense to the computer as anything. The computer completely ignores it. Uh, a much better thing to write in here would be to say, this program demonstrates the use of a function slash slash to return a square of a number. Yay. Okay. So this is something that describes the program. This is where you should put your name, the title of the program, maybe the date that you did it, all that kind of information that if you were submitting it for marks that you'd put in there, or just if you needed to keep track of it so that you're using the same code 20 years later in your class, you can say, wow, I made this for the first time in 2023. All right, then it comes down here, void. This is a function that doesn't return anything when it's all done. It's just done, doesn't have to pass anything to anybody. It's not expecting anybody to pass anything to it because those brackets are empty. This is the bracket that starts it. This is the bracket that ends it. They have to be matched. You can't have a function that has an opening bracket and no closing bracket. Okay, now you'll notice this is formatted very nicely, and the opening bracket and the closing bracket are on the same line, and everything that's controlled by those brackets is indented one line. So that's a great way to keep track and make sure that your code is, what's in between those brackets? Well, it should be indented. All right, at the end of the bracket, we've now finished the void setup, that chunk of code that runs once at the beginning of the program, and we come down to the void loop, the chunk of code that's going to repeat forever and ever and ever on the program. Again, loop is not going to return a function when it's done. In fact, kind of makes sense because it's never going to finish. And there's going to be no values passed into loop. That's just the way the structure of the code is set up. Nothing gets passed into void loop. This is where all of your main code to run the program is. This is where you set your program up, and this is where your program runs. Okay, it comes down here, it executes various statements, and it prints a carriage return at the end of some lines because they have println on them. Now, I've created a function called square. I could have named it Booga. And then to call it, I could just say Booga. So long as I spell it correctly, the computer does not care. But calling it square sure makes a lot more sense. Okay, 0 print line square. And now here I am using the round brackets to put a 5 inside there. That passes the 5 right down here where int square is expecting an integer to be passed to it. That x is now used as a variable in here. So that is 5 times 5. It creates a new variable, integer y, and then it returns that y. And so when this runs right in here, the print statement, instead of seeing the words square 5, sees the number 25 because this code is all crammed into that one statement right there. Comes here and says, oh, before I go and do any prints, I have to come down here, I have to do this, have to do this, keep going until I hit that end bracket, and there's that return statement, done. Then it comes in here and keeps repeating. So what can we do with this a little bit more? Say I wanted the squares of all the numbers from 1 to 10. Okay, well, I could come along and I could just copy this code 10 different times and brute force it that way. That would be really ugly. So instead, what I'm going to do is I'm going to create a variable right in here, and I'm going to call it int counter. And I want it to start at 0. It's important that you tell it that when you define the variable that you declare a value for it, because otherwise it might be a random number, or it might not be. You really don't know what it's going to be unless you tell it what it's going to be. So what I'm saying is that I'm creating an integer type variable, and yes, we'll talk about what the other variable types are in another lesson. No, leave that indented a bit. We're going to call it counter. We could call it Booga. We could call it Bob if we wanted to. um, but we're calling it counter, and we're setting it to 0. And now I'm going to create a for loop. Okay, now you'll remember that we had a repeat 10 times command in some of our drag and drop programming. The for loop works like that. Okay, you'll notice that when I type in words that the computer knows, that they change color and they kind of go pink. So I'm going to say for, and I'm going to say counter equals 0. So counter is going to start at 0. Counter is less than or equal to 9. Let's just say less than 10. It's an integer. Okay, counter is less than 10. Oh, did we want 10 involved? We did want 10. Counter is going to be go until it's less than 11. And then we're going to say counter equals counter plus 1. And now I'm going to create a squiggle bracket right there. Come all the way down here and create another squiggle bracket right there. And now that's like taking those big orange arms and hugging that code in between there. And now I'm just going to change my 5 to say counter. The for loop is super valuable for things like this. So what a for loop does is it comes along here and it says, okay, I'm starting with the counter variable equal to 0, and I'm going to keep doing this loop so long as this condition is true. So long as the counter is less than 11, I'll keep doing that. And each time I finish the loop, I will say the counter now equals the counter value plus 1. So if the counter starts at 0, and we'll go through it, it'll do the whole loop. It'll come up here. It'll say 0 equals 0 plus 1. Okay, counter equals 0 plus 1. Now counter is equal to plus 1. It will do this test right here. It will say, okay, counter is now 1. Is 1 less than 11? Yep. It'll go through and it will do all the code right in here between the squiggles. When it gets to the end of the squiggles, it comes back around here and it keeps repeating forever and ever and ever until we get to the point where counter equals 11. This condition is no longer true and it kicks out right there. What does it do then? Oh, well, then it comes back around here. Let's start the simulation and see what happens. There you go. You can see the counting taking place. If you want to see a little bigger screen. Now, why does it still say 5? The square of, let's stop the simulation. Square of 7 is not 25. The square of 8 is not 25. Can you see what's missing in the code? Should be staring at you. Maybe press pause for a second, take a look, follow it through step by step, and see, can you see what needs to be changed in there? And maybe try it on your code at home. Yeah, I am going to give you the answer, but come on, press pause, take a look through there, and see if you can sort that out at home. Why? It's changing the number right here. The square of that part is changing correctly. Okay, well, I'm assuming you've pressed pause and you've got it figured out at home, and you realized that it was because right in here, I was sending it 5 every time, when what I needed to do was send it that changing variable of counter. And now we've got a function that's going through and sending us the right values. The square of 10 is 100. The square of 0 is 0. The square of 1 is 1. 2 is 4. 3 is 9. That looks like it's returning squares for me. Now, this is a pretty trivial example. If you want to do something more complex, write a square root function. It's one of those things that every beginning programmer in a computer engineering course has to know how to write. How do you write a tangent function? How do you write the, cosine function? And they write them at all different levels for different numbers with different degrees of computing efficiency and different degrees of accuracy. We're lucky. We're just going to stop at writing the square. However, later on, you'll use this for many things where you need to do a repeated action over and over and over again. You'll create your own function, and that will allow you to keep your main code nice and tight because you don't have to put all of that code into your main code. You can have a function and you can debug that separately. And then when you know it's working, you can integrate it into your main code. It lets you break the program down into small parts and make it a lot more efficient. Okay, so that I hope answers some of those questions we had at the beginning that everybody has. What the heck is a void loop? Is there really a difference between the squiggly brackets and the round brackets? Yes. The squiggly brackets are like those orange arms in our graphical coding that contain a section of code. They're very important and they always have to be matched. Every opening bracket needs a closing bracket. Okay, the round brackets contain a value or number that we're going to pass somewhere to another function. They also serve the mathematical function when you're doing math of, setting up your bed mass hierarchy so that you can say, well, do your multiplication first and your addition second. But so they serve that function as well. But the round brackets are really important because they open and close around a number so that or or a string of letters that you can send off to another function. So they show up a lot and let you know that you're using a function to get things happening. Okay, so we took a look at functions. We created a function. We talked about loop, the infinite loop of the void loop statement and the for loop statement. And we didn't talk about the variable definitions very much. I just wanted to touch on a few things about our variable definitions in here. So when we came in here, we set up this integer within the void loop function itself. And down here, we set up y within the square function itself. That makes those local variables. Okay, and that means that the only place in the program that they exist is within that function. My main loop can't see y, and my square function can't see the variable counter. It only sees the counter in the sense that it's passed over here, and the square function knows counter as a different variable called x. Okay, and then it passes y back into right here for printing. If I'd wanted something that could be seen throughout the program, I would define it right up here, and I would call it a global variable. Now, again, I could call it booga 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 if I wanted, but I'll just call it, just a minute, I'm gonna make it an integer variable. Now, I don't have to define it as starting at 0. I could say maybe it starts at 5,000. Okay, so I can say int global variable equals 5,000, and now everything in the program can see global variable. Okay, these ones that are defined within a function are local. So for instance, if I tried to use y in void loop, I'd get an error. But if I use global variable, I can use that anywhere. So why is one more valuable than the other? Well, this is great for setting up parameters for your program, and we'll talk about that later on. So if you want to say what pin your LED is connected to, you could set it up right in here. And then if you decide to change your hardware setup and plug that LED into a different pin, then you can just come to the beginning of your program, and instead of having to look down every time that you turn that pin on or off, if you just find the name of the LED and it's called red LED, you just set red LED to pin 7 in here and you change it once and it changes it everywhere else in the program. So that's a really good use for global variables and global definitions. On the other hand, if you're writing a really big program that's a lot more complex than the simple stuff we do, okay, but if you're writing a really big program, you might have different programmers working on different sections of code. And you don't want their variables messing with each other because otherwise, whoever's writing the square function would have to talk to whoever's writing the setup and the loop functions and say, hey, you guys aren't using a y variable in your code anywhere, are you? Because I want to use the name y, and if I use it, it's going to clash with yours. So global variables really they're fine for the small programs we write. But when you look at big programs that are shared between many programmers and have many different functions and programs all working together, it's very important to keep variables and code local and just pass the expected values back and forth from one section to the other. So there we go. There's a little more information on our local and global variable definitions in the Arduino IDE. That's a bit of background. I don't have a specific assignment coming away from it. I hope you've been able to create a square function and understand what's going on there. I hope you were able to troubleshoot the little glitch that I left in the program. And we're going to come back in the next video and we're going to talk about what some of those variable types are. We're going to talk about binary. Oh yeah, we're going to talk about binary a lot. And we're going to come up with a program that uses some of these functions to count on a 7-segment display. See you in the next video.